Hey guys, welcome back to my channel. This is Varun. So in the previous sessions, we have seen how do we extract data from various sources and do simple analysis using Pandas library. So in this session, we will try and understand the usage of visualization tools in data analysis. So here we will first look at some online examples of data analysis using some online available tools, and then we will gradually shift our focus towards building our own graphs and charts and doing data analysis. Now let me tell you how our mind perceives some images and pictures. So you guys can see on the screen that there is an image. So can you relate this image to any of the image you have seen earlier? Exactly. So this is a ship or a boat, you can say. So how did you perceive this? This is exactly how you perceive other things also, because you have seen this picture earlier and it resembles a ship or a boat. Now, what if I tell you that the small curvature over here with the structure is an anchor to this ship? So next time, whenever you come across to a similar picture with a kind of similar structure or a curvature, you will try and relate this picture to that, and you will immediately come to know that this will be an anchor. So you guys might already know this, but studies have also confirmed that since many years, our minds have been trained to read visual data much more accurately than any other form of data. So the reasons for this are many, some of which being that our brains are made for visual processing. And since we are seeing things since the day one of our existence, this is the simplest means for understanding anything. The second reason is that colors captures our attention. So you guys might have noticed that several companies like Twitter, Facebook, and many other companies follow a color coding of blue in their logo. So why is that? That is because blue is pleasant and it is more attractive to our eyes. The third reason is that we tend to add emotion to the colors. Like for red, so you can say that it resembles passion or anger, and in case of white, it resembles sereneness or cleanliness or even peace. So the fourth reason is that we can relate things through visual perception and we can create stories of our own so that it is easier to remember. So in data analysis also, we would need a convenient way to interpret our data in visual form, as data visualization can improve the data density as well as the amount of information to convey the data. So let's do some analysis. So for that, I have collected use cases from Gramener website. So the site you're looking is Gramener, and the data which you're looking is currently for ODI Indian batting records collected over the years. So this is the beautiful representation of data analysis on the data collected over years for various batsmen in various countries. So here you can observe that the area for each of these squares will represent the number of runs for that particular batsman, and the color will represent the strike rate of that batsman. So like Sachin has over 87.1% of strike rate and with 18,426 runs, which is the maximum among the other batsmen. So we can also go over other countries and check the batsman records over the years. So here you will see that green represents the maximum run rate scored. So let's look at who scored the maximum run rate. So here it is Sehwag. So Sehwag has almost 8,273 runs and 105.4 strike rate. So let's say that we don't have this visual with us, okay, and we are just looking at the data. Just looking at the data, we cannot just conclude that who was the greatest run scorer with the greatest track record of run rate as well. But this visualization gives us a beautiful representation over all of the analysis that we are looking for. Now let me tell you where this analysis will be helpful for us. So let's check some of the batsmen which has the greatest strike rates. Okay, so there is one batsman named as Joginder Sharma who has 120.7 as a strike rate, which is greater than, you can see, Yusuf Pathan and any other player, even Virendra Sehwag. But you can see here that he has very little runs, that is 35 runs only. So we cannot regard them as having the greatest strike rate because he hasn't played much matches and he hasn't even scored much of a runs. So we have to take care of both the runs as well as the innings and the strike rate. So in that, Virendra Sehwag has the maximum of all, which is 105.4. Now we can further bifurcate this. So when you click on Sachin Tendulkar, you will see his individual innings also, and along with his runs and strike rate in that. Okay, so this is more of a further bifurcation within the similar segment of visualization. Now just imagine how difficult it would be to interpret this kind of data in a spreadsheet where each of the innings of the batsman is stored alongside his run rate. So data visualization comes handy in this kind of scenario where we will get enough of insights just looking at the graphs. Now let's look at one more example of data visualization. So you can see on the screen that this has market movement on budget for the particular years. So this will have the various stock market segments and how they react on the budget which is given on a particular day and a particular year. So as and when the budget is announced, various sectors of stock market are affected, and this graph or this representation of visualization shows us either negative or positive effect on various segments of the stock market. Okay, so here you will observe some of the sectors like tobacco is always growing in various years irrespective of the other segments going down. So here you will see that it is always green. Okay, so this way you can analyze the data better and you will be seeing the hidden insights of the data through visualization. So here you guys can observe that it has also given some narratives or explanation and not just the visuals. So this is really important alongside the visualization aspects as well, because visualization gives us a non-linear picture of the data and it is up to the user or the observer to interpret it as in how he wants. So giving user the option to check the cues or explanation for that data will have no doubts on his understanding as well. So this is really important. Now let's look at one more example of visualization. So the one which you are seeing on this screen is a software ecosystem which is clustering of several software bases on the common grounds of features. So here you will see that if I hover over or select this cluster, it will have certain software here, and if I select this cluster, it will have different softwares here. So basis on its usability and the number of features provided by these softwares, these are clustered. Okay, and these are connected with each other in form of a graph by nodes and edges. So let's see that which all features these cluster provides. So you can see by looking at the description itself that it will have certain kind of playing features and along with some format support in it in each of these softwares. Now let's look at another cluster. So if I select this cluster, you will see that it will have some recording facility and some viewing facility which is different from the other cluster. So it is more on the audition or the recording side of softwares in music section, and this is more on the playing side of the software, which is different formats. Now that we have looked into some of the visualizations examples online, let's try and create our own graphs. So before jumping into creation of the graphs, we have to understand the data. So there are two types of data. First is quantitative data that can be categorized further into discrete and continuous data. So discrete data is the one which we can count, like number of apples here in this screen, and continuous data is basically the measure of the quantitative data, that is the weight or height of these apples. So basically the quantitative data are the ones which we can count or measure. So these can be numeric data, and the other type of data is the qualitative data, the one which represents the categorization of data. So here in the second image, we can categorize this image as the type of fruit, which is dry fruit. Now we will take the example of Titanic dataset and categorize each of the columns to continuous and discrete columns under quantitative dataset and the qualitative datasets. Here you can see that survived, P-class, SIB-SP and PASH come in discrete quantitative dataset, and age and fair comes in continuous quantitative dataset. Also sex and embarked can be marked as qualitative or categorical data. Now let us see each of the charts one by one. So first one is bar plot. So the first plot at top left corner of the screen, you can see here that this is a bar plot, and this is giving us the frequency of occurrence of each of the categorical and the discrete variables. So here it is counting the number of survived passengers. So the number of survived passengers will come at 1. So survived, you can see 0 means those are not survived ones, and 1 is for the survived passengers. So these can either be plotted vertical or horizontal. Now let us look at group bar plot. So group bar plot comes into picture when we want to analyze or compare between two discrete or categorical variables. So here we will give hue as a third parameter. So here you can see that along with the count of survived and non-survived passengers, it has also compared along with the sex of the survived and non-survived passengers. So this comes into picture when we are doing bivariate analysis. So we will be seeing these graphs one by one when we will be introduced to the matplotlib and seaborn libraries in Python. So here in the group bar plot, you can see that number of female passengers which are survived are more than the male passengers which survived. So here it will give you a clear picture over comparison over different variables. Now moving on to scatter plot. So scatter plot is useful when we are trying to set the correlation between two continuous variables. So in this case, which are age and fair. So here you can see that there is no particular correlation because it is not having any particular pattern here. Now let's move on to histograms. So histograms are a means of viewing the numerical values, distribution of numerical values basically. So here you can see that age is normally distributed and fair is basically right skewed. So you guys have to notice one thing here, that before plotting anything to histogram, one must create some bins. So bins are nothing but few ranges. So just like the range for age, you can see here that 0 to 20, 20 to 40, we have to bin it. So Seaborn gives us flexibility that it defaultly creates the bins. So we will see that later. Now let's see how and why we use box plot. So box plot is used for checking the distribution of data. Basically the data which is lying under a certain value, and to identify the outliers and mean and median and minimum and maximum value out of it. So the box plot is used for only the continuous variables. So here you can see that it is plotting age in the box plot, and there are some outliers here you can see, and the mean, medians and minimum. So we will look at this box plot comprehensively. So this gives us the meaning for using the box plot. Here you can see that it will fetch us the minimum value, the maximum value, and it will also identify the outliers on the data, and it will identify the median, that is the 50% of data, the 25% of it, and 75% of it. So these parts are called as quartiles. So this will give us the interquartile ranges of data. Now let's look at heat map. So the plot at the top right corner of the screen is showing the heat map. So heat map identifies the correlation between two variables. So the positive value in the heat map indicates the positive correlation, and negative indicates the negative correlation. So positive correlation means when one variable goes up, the second variable also goes up. So it is kind of a direct relationship between them. And the negative correlation indicates that those two variables are negatively related, that is inversely related. If one goes up, then the other goes down. So 1 is basically meaning that it is perfectly correlated, and 0 means that it is not even related to each other. So here you can see that P class and fair are negatively correlated, which is high negative correlation of 55%, and SIB, SP and patch are positively correlated by 41%. Now let's look at line plot. So this age versus fair is a line plot, and this is pretty intuitive when we are plotting between two continuous variables. So in this case, age and fair. This is most useful when we are plotting on a time series data, so as to compare the trend of a continuous variable with time. Now let's look at group box plots. So the bottom right corner of the screen is the plot for box plot, and it is mainly used when we are trying to compare between a categorical variable with a continuous variable. So it will give us the distribution there. Okay, so this is giving us age versus sex box plot. So the blue ones are the males and the orange ones are the females. Now the last one is the pie plot. So pie plot is similar to a bar graph, but mostly deals with the categorical fraction. Okay, so here you can see that mostly 65% of the females were onboarded on Titanic. So this will give us a clear picture of how much was the total percentage and how many are segregated to each of the categorical variables. So guys, this brings us to end of today's session. I hope you liked it. Please like, share and subscribe my channel if you are looking forward towards more awesome content on data science. So I'll be covering more visualization concepts further in next sessions, along with matplotlib and usage of seaborn libraries. Until then, please take care of yourselves and your family. Thank you.